Okay, so in this video we want to look at how to solve the trig equation cosine of x plus tangent of x minus 2 cosine squared of x is equal to -1. And we want to find all of the angles one lap around the unit circle, so from 0 to 2 pi, and that's an inclusive interval. So first thing we want to do is take a look at this cosine times tangent. Whenever we see a product, we can go over to our Trig Identity Hexagon that helps us recall the fundamental trig identities, and a product is always a hinge. So here's our cosine, here's our tangent, and they meet in the middle with sine as the hinge. So the product of tangent and cosine is sine. So we're going to apply that product identity first in the equation and rewrite cosine of x times tangent of x as the product sine of x. And then that's minus 2 cosine squared x equals -1. Okay, then since our goal is to try to write this trig equation in terms of all one trig function instead of sines and cosines, we want to try to get all cosines or all sines, and there's no way to change just plain sine of x into cosine of x. There's no identity that will do that. But when we see a squared trig function, so here we've got a cosine squared x, that should ring a bell to remember the Pythagorean identities. So when we come back to our trig hexagon and remember Pythagorean identities, those come from the triangles in the hexagon. There's 3 triangles that represent the Pythagorean identities. So this one up at the top, then this one on the left, and this triangle on the right are the Pythagorean identities. So tangent squared x plus 1 equals secant squared x. 1 plus cotangent squared x equals cosecant squared x, or the one that we're going to use up at the top, sine squared x plus cosine squared x is equal to 1. So sine squared x plus cosine squared x equals 1 is the Pythagorean identity that we're going to pull from the hexagon and apply in this situation. But we need to substitute just the value of cosine squared x into our equation, which means we need to solve this identity for cosine squared x, and we'll do that by subtracting side squared x from both sides, and then cosine squared x is equal to 1 minus sine squared x, and that is what we're going to substitute into the equation. Now we have to be careful because this is a -2 as the coefficient on the cosine squared x, so when we're rewriting sine x minus 2, we're going to need to encase the substitution in parentheses so that that -2 coefficient applies to the entire identity, 1 minus sine squared x, which we got from our Pythagorean identity with the trig hexagon. So now we can go ahead and distribute to get rid of these parentheses. So we'll have sine x in the front minus, and then 2. Then -2 times negative sine squared x is a positive 2 sine squared x equals -1. Okay, so we'll put our quadratic term first to write it in standard form. So 2 sine squared x will go in the front, then our linear term plus sine x, and then our constant minus 2, and that's equal to -1. Since this is quadratic, we remember that we need to get it set equal to 0, so we can either factor or use the quadratic formula. So if we add this 1 over to the other side, we'll have 2 sine squared x plus sine x, and then -2 plus 1 is a -1 equals 0. Okay, now some students find it difficult to factor in this form, And if you would prefer, you can pick any letter you want, just reassign that letter. So maybe we'll try, let's try the letter B. So let's say B equals sine of x. We're going to reassign everywhere we see the expression sine of x, we'll replace that with a B. So that's a 2b squared plus b minus 1 equals 0. And that just makes it a little easier to look at when you're trying to factor. So however you learn to factor, you can go ahead and do that. I'm going to use the crisscross and the box graphic organizers to help me factor this quadratic trinomial since the leading coefficient is greater than 1. So when you're doing the crisscross and the box approach for factoring, you're going to multiply your first term and your last term. So 2b squared times negative 1 would go up here, and that would be a negative 2b squared. Then your middle term, the b, is going to go in the bottom of the crisscross, and then you ask yourself what are the factors of negative b squared on the top that add to equal this b on the bottom. And that would be a 2b times a negative b. 2b times negative b is negative 2b squared, but 2b plus negative b is b on the bottom. And these factors are going to go into the box like this. They're interchangeable, so you could have put the 2b in the bottom and the negative b on the top. Either way is fine. Okay, then back to our original trinomial. The first term, the quadratic term, goes in the first box, so 2b squared. The constant goes in the last box, negative 1. And then we're going to go across each horizontal and up and down each column looking for the GCF. So 2b squared and 2b have a greatest common factor of 2b. Negative b and negative 1 have a greatest common factor of negative 1. Then up and down the first column, 2b squared and negative b have a b in common, and 2b and negative 1 in the second column have just a 1 in common. And those will be the factors, 2b minus 1 and b plus 1. So we'll write those factors, 2b minus 1, b plus 1, and that equals 0. So we used that substitution of the b just to make this easier to factor. Now let's go ahead and put it back. So since b is equal to sine of x, this is 2 sine of x minus 1 times the quantity sine of x plus 1 equals 0. Now we can apply the zero product property. So each of these will be its own problem. So if 2 sine of x minus 1 equals 0, then 0 times this factor is 0, and it's true. If the sine of x plus 1 is equal to 0, then this would be a factor times 0, which equals 0, which is also true. So that's how our zero product property works. So we solve each of these factors set equal to 0 independently and find what x equals. So in this case, we would add 1 to the other side. We would divide by 2, and sine of x would be equal to 1/2. And then to take the inverse of both sides, we'd end up with x equals the arc sine of 1/2. So we would be looking on the unit circle for all of the angles from 0 to 2 pi that have a y-coordinate of 1/2, since that's what the sine function means, is the y-coordinate. And that first answer would be found at pi over 6 on the unit circle. Okay, now that's an answer from the first quadrant though, and if you remember, all students take calculus. There is another place in quadrant 2 that has a positive sign value. So if we have our quadrant 1 answer, we need to reflect that into quadrant 2. So we'll do that over here where we've got some room. So here's pi over 6 in quadrant 1, that's our reference angle. To go halfway around the circle would be 6 pi over 6. So to get the same size angle in quadrant 2, where sine is also positive, we would subtract pi over 6. So 6 pi over 6 minus pi over 6 is 5 pi over 6. So that's our second solution for the first factor, 5 pi over 6. Okay, now our second equation, sine of x plus 1 equals 0. We're going to subtract 1 from both sides. Sine of x is equal to -1. Then we'll take the inverse of both sides, and x is equal to the arcsine of -1, which means, again, we're going to look on the unit circle from 0 to 2 pi for any places where the y-coordinate is equal to -1. And that would be a quadrantal angle along the negative y-axis, which is 3 pi over 2. That's where the y-coordinate is -1. Now, we still need to check these answers because it's possible that either we made a mistake and we would catch it when we checked it, or that something might be extraneous and we would have to throw it out if it was outside of the domain. So let's slide back up, see if I can make this a little higher so we can see everything at once. There we go. That's better. So we want to always check our answers in the original equation. So this is what we started with at the beginning. Cosine of x times tangent of x minus 2 cosine squared of x equals -1. So we'll go ahead and get the calculator, and we want, let's see if I can make this so you can see it. So we want to turn on the calculator and first check that the mode is in radians, which it is. Okay, and then we're going to go to our answer, pi over 6. And we want to hit the store button. So we'll store that STO as x and press enter. And then we're going to type in our original equation. So cosine of x times tangent of x minus 2, and then cosine of x, and that gets squared. And to get the equals, we go to second math. Number 1 is the equals, and then we want that to equal -1 here on the other side. Now, whenever you use the equals from the test menu, that means we're asking the calculator a question about whether this checks or not after it substitutes in the pi over 6 for all the x's. When we press enter, if the calculator says 1, that means it checks. If the calculator says 0, that means it doesn't check. And if it says error, that means it might be extraneous, and we'll have to look into that further. So we'll press enter, and we get a 1, which means that pi over 6 checks as an answer. Okay, now we're going to check our second answer, 5 pi over 6, and we're going to store that as our new value of x. And then we don't have to retype that whole equation. We can just arrow up to it so it's highlighted, and then press enter, and then enter, and we get a 1 again, so we know 5 pi over 6 also checks. Okay, now we're going to check, last but not least, the 3 pi over 2. So we'll store that as x, and then again we'll arrow back up to that equation, and then press enter, and this time we get error domain. Okay, that means that this 3 pi over 2 is causing an error in our original equation, and when we look back up here, right, there's a tangent ratio times a cosine. We've got places here where something is causing this to be outside of the domain. So this answer we have to throw out and write extraneous. EXTRANEOUS, extraneous. Extraneous means it's a solution that it's not because of an algebra error that it's occurred. It's just in the nature of the problem that we started with. We end up with a solution that isn't going to work. Okay. So our two solutions then for this equation that check are pi over 6 and 5 pi over 6. Hope that helps.